3.2 Geometric Properties, Review of Angle Theorems. So some key ideas in this lesson here are parallel lines are always the same distance apart, therefore they never intersect. So these are parallel lines, right? Parallel lines. No matter where you go from, and this spot here, this is always the same distance. This spot here, this is always the same distance no matter what. So these are parallel lines. A line that crosses two or more parallel lines is called a transversal. So here's a line that crosses the two parallel lines. This is called a transversal. And for the angles formed by a transversal and parallel lines, you have several cases here. Opposite angles are equal. So we're saying this angle over here is equal to this angle over here. Same thing if I said this angle over here will also equal this angle over here. Corresponding angles are equal, so they form an F. So if you notice, we have an angle here and we have an angle here. These are going to be equal, okay? And similarly, even on the other side, if you reverse the F, you have an angle over here, which will be equal to the angle over here. Co-interior angles add to 180 degrees. So here's two parallel lines. The transversal inside are my interior angles. These two angles add up to 180 degrees. Okay, the picture might be a little bit confusing. C and C does not mean that they are the same angle. They're just trying to show you that this form is a sieve, and that the two angles here add up to 180 degrees. And you can also reverse your C, invert your C around. You can say these two angles also add up to 180 degrees. I shouldn't also show that this way. So let's just show them like this, two different angles. Okay. Alternate angles are equal. So if you see a Z pattern here, so two parallel lines and transversal make up a Z shape here, either inverted or the right way. What they say is that this angle up here is equal to this angle down here, the alternate angles. Okay, so a couple of theorems, complementary angles here. So if we have a line segment AB being perpendicular to BC, this is the sign for perpendicular. It signifies that this angle here, X and Y, when I add them together, they have to add up to 90 degrees. Supplementary angles. So if you have angle ABC is a 180 degree angle. In other words, you see a straight line segment here. Then the angles that you see here, X and Y, X plus Y, have to sum to 180 degrees. And X and Y are separated by this line segment BD. We call also, by the way, we call these supplementary angles. Y supplementary to X, because it's just a relationship between 180 degrees, subtracting X to give me Y. Right, opposite angle theorem. If AC and BD are line segments intersecting at this middle point E, then we have a case of opposite angles here. X equals Z and W equals Y. And finally, the sum of the angles in a triangle. If you have in any triangle, whether it's isosceles, equilateral, any triangle, even a right angle triangle, and any triangle, all interior, the inside angles, sum to 180 degrees. So that means X, Y, and Z, when I add them together, add up to 180 degrees. Okay, so I want you to use these angle properties to figure out some practice problems. I have some practice questions for you to do. Before you jump into the practice questions, I just want to show you one example on how to use equations to help you find an unknown value for an angle. So here's an example of creating equations to solve for unknown angles. So what you see here is a straight line, okay? And we have another line segment here. So that's dividing these two angles, this one over here and this one over here. And I'm going to use this rule that says the sum of these two supplementary angles, or this one up here, remember this one? Supplementary angles, this rule right here. So the addition of those two angles have to add up to 180 degrees. Okay, so back to the question over here. I'm going to say, okay, So this angle here, 2x minus 50 plus 3x plus 20 have to add up to 180 degrees. So 2x minus 50 plus 3x plus 20 have to add up to 180 degrees. So I've just created this equation, and I can solve this equation for x. Okay, so I'm going to remove the brackets, 2x minus 50. You do want to start off with brackets just in case you do run into the situation where you are subtracting angles, so that minus sign could make a difference. Here there's no minus sign in front of the brackets, so every term stays the same. Okay, but you solve this equation just like any other from our previous cycle. You collect like terms on the left side, so 2x and 3x make 5x, and negative 50 plus 20, or minus 50 plus 20 is minus 30, okay, and that equals to 180. And if I add 30 to both sides, I will get 5x equals 210, and if I divide both sides by 5, I'll get my answer. So I divide this side by 5 and this side by 5, I get x equals 42. And there's my answer for x. So if I'm asked for to order the angles, then I just take 2x minus 50, which would be 2 times 42 minus 50, and that equals 34 degrees, and that means the other angle is going to be 180 minus 34. 146 degrees. Okay, so you can also use equations to help you find unknown angles.